Good day, everyone, and thank you for being here. At this stage of the crypto cycle, showing up is not only appreciated, it's meaningful. The fact you're sitting here tells me something important, that you still believe that decentralized infrastructure matters. You believe that the cloud should be owned by the people who use it, not by a handful of corporate or governmental stakeholders. And most importantly, you believe that sovereignty, the real technical sovereignty, not the marketing slogan type, is worth building. Today marks a major milestone for our project and our community. We've been through years of evolution, experimentation, setbacks, and breakthroughs. We've solved engineering challenges that few projects have even attempted. And through all of that, we've learned something essential. The future of the cloud doesn't belong to the companies with the biggest data centers. It belongs to the networks with the strongest alignment between users and providers. That's the story we're here to tell today. Where we started, why we chose to do a full reset, and how the virtual private data center gives us a foundation for the next chapter of digital autonomy. But to understand where we're going, we need to talk honestly about where we've been. Let's start with the truth we don't shy away from. We needed a reset in more ways than one. For years, we believed early, small and medium enterprise customers, especially those connected through our angel investor network, would immediately see the value of distributed object storage as built by us. After all, they did write checks to see it produced. Reduced cost, geographic redundancy, inherent durability, resistance to single point failures, these are all compelling advantages. And to our credit, the network did grow rapidly. The infrastructure matured along the way. We solved core challenges early, but the adoption still didn't come. We just didn't find a niche that made early traction easy for those folks. We didn't land a breakout partnership. We pursued promising verticals like video management systems. We produced case studies. We even brought in industry specialists. Still, the breakthrough didn't arrive. And in a startup, especially in infrastructure, time is expensive. So we paused, evaluated, and finally pivoted. This reset is not a restart. It is a realignment. It forces us to ask a difficult but necessary question. What do we truly control? The answer isn't enterprise customers. It isn't a marketing budget. It isn't institutional backing. The only thing we can control is this community and the infrastructure that it built, the providers who believed early, the contributors who showed up when no customers did, the people running hardware in homes, offices, and small data centers around the world. With the reset, it is clear. Our path forward doesn't depend on convincing enterprise first. It depends on activating the people who already believe in the mission. The reset means looking inward, too. Early on, remote work was a gift. We were fast, creative, and enjoying ourselves more than should have been allowed. But fully remote teams spread across cultures eventually drift unless structure is intentional. Without shared norms, remote work becomes a collection of tiny kingdoms, fiefdoms, each with its own priorities and unspoken assumptions. We saw this clearly in building a billing system. One has to assume it was one of the first reliable systems that AWS built. And it's the only system at AWS that never goes down. Our contract engine is the most stable system in our stack, and the handoff from there to customer payment should be easy and clean. But instead, because of misaligned focus, multiple developers independently and in parallel attempted to build a full e-commerce suite from scratch, and that ended up in flames. So our reset isn't just product strategy. It is cultural. It is structural. It is a return to doing the essential things first, and that discipline is now part of how we build going forward. During the early phase, we attempted to onboard or create MSPs within our own network. The people interested were already bought in financially, so we assumed that they would be natural adopters, able to gain significant early storage use. What we didn't understand at the time is that they had a silent concern. Introducing blockchain-based infrastructure into their traditional SME clients poses a risk to reputations, and their entities wouldn't bet their businesses on a decentralized architecture. So we learned another important lesson. MSPs and SMEs don't adopt technology, they adopt trust. Our response was a partner program with developed training content, a distribution strategy. But for now, this must wait until adoption happens. To understand why the virtual private data center matters and why this reset is so important to the project, we need to zoom out and look at what has happened to the cloud over the past decade. Because the truth is simple. The modern cloud is failing the people and organizations who rely on it. The cloud began with a beautiful idea: abstraction, scalability, and universal access to compute and storage. But in practice, it consolidated faster than almost any other technology sector. A handful of companies now control the infrastructure that underpins governments, enterprises, startups, medical systems, school districts, critical services, and increasingly the AI models that are shaping our daily lives. And with that consolidation comes something else: a shift in the balance of power between individuals, corporations, and governments. Cloud providers are not merely vendors anymore. They are identity managers, data custodians, metadata aggregators, analytics engines, security arbiters, political choke points. And because their services sit directly in the path of your digital life, their understanding of who you are is not inferred. It is measured. This brings us to metadata. The industry likes to pretend encryption solves privacy. Your files are encrypted, so your data is safe. But anyone familiar with modern cloud architectures knows the truth. Encryption protects content. Metadata reveals behavior. And behavior is more valuable than content. Metadata tells a cloud provider when you upload, how often, how much, who you share with, where you are, what devices you use, how often you sync, what times of day you're most active. Aggregated metadata creates patterns, and patterns create profiles, and profiles create predictions. This is why centralized clouds have become one of the most powerful surveillance tools on the planet. By accident at first, then by convenience, and now by explicit cooperation with governments and regulatory bodies. We're not headed towards centralization. We're already living inside it. And the more AI-driven our world becomes, the more dangerous this alignment becomes. The major cloud providers are no longer neutral service providers. Their scale forces them to align with governments because they require regulatory approval for international data flows. They operate data centers in sovereign jurisdictions. They manage encryption keys under legal mandates. They must comply with national security requests. They face political pressure around data access, AI models, and content moderation. This isn't dystopian prediction. It's how the modern cloud works today. If a government wants access to metadata or access logs or usage pattern, it typically gets them. Sometimes through legal orders, sometimes through compliance frameworks, and sometimes because the architecture itself can't avoid leaking metadata up the stack. For individuals, for journalists, for organizations in sensitive corners of the world, and for nations outside the Western political sphere, this is a growing threat. So this is the reason decentralization matters, now more than ever. Decentralized infrastructure isn't simply distributed computing. It is distributed metadata, trust, jurisdiction, value, influence. It removes choke points because data is not concentrated. It reduces surveillance because no single entity sees the whole picture. It increases resilience because ownership is shared. It reduces governance capture because infrastructure lives across borders and cultures. In a centralized cloud, sovereignty is simulated. In a decentralized cloud, sovereignty is structural. And the virtual private data center is the direct embodiment of that principle, not as a slogan, but as a functional, configurable, user-controlled cloud environment. There's one more shift happening that magnifies the importance of this moment: the explosion of AI-generated data. Large language models, image generators, video models, speech models, simulation engines, they're all producing terabytes of object storage demand. Entire industries are shifting from structured to unstructured data. And in the next 5 years, the world will generate more data for AI systems than all human-generated data in history combined. Where does all that data live today? S3, Blob, cloud storage, we know the names, all centralized, all metadata rich, all government aligned, and all expensive. AI is becoming the largest consumer of object storage the world has ever seen. And the providers of that storage will effectively become the quiet governors of the AI era. That is a future we cannot allow to be monopolized. A decentralized cloud, one built around VPDs, gives individuals, organizations, and even entire nations a way to participate in the AI future without surrendering their sovereignty to 3 Western hyperscalers. If the broken cloud explains why decentralization is necessary, the virtual private data center, the VPD, explains how we deliver it. The VPD is not a metaphor. It is not branding. It is not a vague idea wrapped in nice language. The VPD is a functioning layer in architecture that gives every user a configurable, private, software-defined data center built on top of a global network of independent storage providers. This means the VPD does for cloud sovereignty what VPNs did for network privacy, except instead of routing traffic, we route and control data itself. A virtual private data center is a personal cloud inside a distributed cloud. It's a user-controlled layer where you define which providers store your data, which regions your data can or cannot enter, how many redundancies you want, what level of performance you require, how much you value durability versus speed, how your data life cycles across tiers. And because the network is decentralized by design, metadata exposure is dramatically reduced. No single provider sees your entire data pattern. No hyperscaler sits above you in the architecture. No centralized actor can profile your usage. This is a different model of cloud entirely, one where you command the infrastructure instead of renting slivers of a corporation's infrastructure under their terms. But the VPD is more than sovereignty. It's also strategy, because it's how we solve adoption. Originally, we believed small and medium enterprise would lead adoption. It made sense on paper. Enterprises store massive amounts of data. They value durability. They like redundancy. They're cost sensitive. They already use S3 compatible workflows. But enterprise cycles are slow. MSPs are cautious. CIOs want references before risk. Integrations take time. And none of those realities aligned with a small team trying to break into a mature market. So we made the shift that all great infrastructure projects eventually make. We turned inwards. Providers believed in the mission before anyone else. They put up the hardware. They ran nodes through market cycles. They provided capacity without seeing customer demand yet. They helped us discover bugs, performance characteristics, network thresholds, long before any enterprise would have even answered our email. And most importantly, providers want this network to succeed because it is theirs. This is the core difference between decentralized infrastructure and enterprise-first cloud. In our world, the users are also the infrastructure, so we embrace that reality. This summer, our engineering team made a major breakthrough. We optimized the VPD and personal cloud layers to run smoothly, even on light hardware configurations like the examiners. This allowed us to do something we couldn't do before. Load full VPD capability directly onto 2,000 provider nodes. This means providers can use the system themselves, become our first customers, generate real-world telemetry, give real UX feedback, and stress the network in a controlled environment, and validate the product before enterprise onboarding. This is how we bootstrap a cloud, by turning the community into the earliest of adopters. To accelerate this feedback loop, we're allocating free storage to the community, not as a promotional gimmick, but as a recognition that the people who built the network deserve to use the network. These grants accomplish several things at once. They generate real usage patterns and force the UX to mature faster. They reveal friction that we need to fix and strengthen the network with meaningful telemetry. And they allow providers to compare their own nodes against the network. They create the beginnings of an actual usage economy. When the product works great for providers, when the VPD works for providers, when personal cloud becomes part of their daily flow, that is when the story becomes credible to SME and enterprise. It's the same principle that built early content networks, early mesh networks, early compute networks, and early cryptocurrency networks. The system grows from the inside outward. Let's be clear, personal cloud is not a consumer play. It's the ignition layer for a much larger machine. Here's why. It gives non-technical users a reason to try the network. And it creates emotionally meaningful data, photos, videos, archives. It forces us to build a great UX instead of a technical demo. And it transforms providers from passive infrastructure farming in closets into active users. And it generates the internal adoption curve we need to validate the platform. Once the adoption curve is real, once thousands of providers are storing and safeguarding their own data through the VPD, then the enterprise value proposition becomes undeniable. If the network is good enough for the people who run it, it is good enough for the companies who want to use it. Personal cloud is not a detour. It is the launchpad. If the VPD is the architectural breakthrough, the economic model underneath it is the revolution. Cloud pricing has always worked one way. You pay forever. You pay for every gigabyte stored, every request, every egress, every lifecycle transition, every replication event. And the more data your organization generates, the more you pay. It's not simply a cost structure, it's a treadmill. AWS created the S3 storage market. Their engineering is brilliant. Their uptime is world-class, mostly. And their scale is unmatched. But their economics are also designed to extract maximum lifetime value from customers who can't leave. Once your data lands in S3, you're effectively captured by egress fees and proprietary tool chains, regional lock-in, complex lifecycle pricing, opaque metadata usage, and the operational risk of migrating away. Companies like Backblaze and Wasabi have attempted to undercut this. offering attractive prices as the headline. Wasabi even advertises 80% cheaper than AWS. But the model doesn't change. It's still centralized data centers, centralized overhead, centralized CapEx, and centralized margins. Distributed storage breaks this model entirely. In the distributed data center, the user is not merely a customer. The user can be a provider. They can run a node on the same equipment they use for their personal VPD. And when they provide storage to others, they earn revenues. That revenue can offset their own cloud expenses. This dynamic creates a cost curve no centralized cloud can match. And it's our unfair advantage. Your usage generates cost. Your node generates revenue. The two converge. Long-term TCO trends toward zero. In many cases, the device becomes net profitable. This isn't a promotional discount. It's economics. It's the natural outcome of distributing CapEx across thousands of providers instead of consolidating it into a handful of mega data centers. Using industry baselines, AWS S3 standard, $23 a terabyte. Wasabi, Backblaze, $5-6. Distributed data center, $5 a terabyte is a starting point, but falling over time. Where centralized clouds have fixed costs, we have negative cost potential. The longer a provider participates and the more they contribute, the more their cloud costs shrink. No hyperscaler will ever publish a pricing page with a downward sloping curve. Let's look at the 3-year curve. Here's what happens for the medium provider user pairing. In year 1, you pay around $5 a terabyte or less with grants, while your node begins generating revenue. By year 2, your effective cost drops to $2 to $50 to $3 a terabyte as your node's earnings offset your usage. By year 3, depending on how much storage you provide, your TCO crosses zero. The device is paying for your storage entirely. In some cases, it becomes profitable. That curve is only possible because the distributed data center spreads infrastructure pressure across the entire network rather than concentrating it in costly centralized real estate. And this will only come true when we achieve widespread and wide-scale adoption. And that is why getting the nodes operational internally for providers is so important to turn the dial on internal adoption and get the cloud moving forward. So let's widen the lens even further. Most decentralized networks talk about regional placement only in the context of EU regulations. But the implications are much larger, especially for the global south. Let's take the fictional nation of Cachemir. And we're spelling Cachemir Cachemir. Oh, let the sun beat down upon my head. Cachemir wants a cloud industry. It wants digital sovereignty. But today, almost all of its data flows out of the country and north to the EU, to the USA, to a place where there are data centers for the big three. Nearly all cloud spending leaves the local economy. Local businesses depend on US and EU tech giants. National security risks grow as foreign entities host their core data. Now imagine what happens if Cachemir deploys RelayerXM nodes nationwide. A government-aligned organization installs the initial backbone. The country offers subsidized storage to local businesses. The data stays in Cachemir. Money stays in Cachemir. Local providers earn revenue. A sovereign cloud emerges organically. This is not theory. It's a blueprint for economic transformation that can happen today on our network. Instead of paying AWS, Cachemir pays for its own people. Instead of exporting capital, it circulates wealth. Instead of renting infrastructure, it builds it, distributed, resilient, and sovereign. The distributed data center is not just a technical architecture. It is a development model for nations who want digital self-determination. Okay, we've talked about cost, sovereignty, decentralization, and the VPD. Now let's widen the lens again and look at the biggest technological force reshaping the world today: AI, large language models. And let's be clear, AI is not a future driver of storage demand. It is already the largest and fastest growing consumer of data object storage on the planet today. Every modern AI workflow requires massive quantities of unstructured data. And all of that data, raw, curated, transformed, chunked, embedded, vectorized, lives in object storage. Not databases, not file systems, object storage. This means the AI economy runs on the very thing our network specializes in. It begins and ends with object storage. First off, data lakes, the AI foundation. Cloud providers position S3 and blob storage as the backbone of data lakes because object stores handle multi-petabyte scale that can handle billions of objects, all using unstructured file types with long-term durability and cheap cold storage tiers with lifecycle transitions. Every AI system, from small models to frontier-scale giants, begins with data lakes built on object storage. There is nothing inherently centralized about this. Second, training data and pre-processing. Training pipelines use object stores to stage raw data sets, store pre-processed data shards, hold evaluation sets, and write batch inference outputs. Active training hits fast file systems, yes, but everything before and after sits in S3-styled object stores. The VPD replicates this pattern: cheap, durable, S3 compatible, and sovereign by design. The third one are RAG and knowledge bases. Retrieval augmented generation has exploded as a paradigm. There are now two kinds of RAG data: the original documents and the vector embeddings. Both can live in object storage. AWS now offers S3 vectors, which stores embeddings directly in object storage, validating that AI doesn't require a centralized proprietary database. Once we solve internal adoption, the distributed data center can become a decentralized backbone for RAG workloads as well. 4. Model artifacts, experiments, and logs. ML engineering teams store everything in object storage: model checkpoints, training logs, valuation metrics, experimental outputs, batch-generated files. Much of this data is read rarely and written often, ideal for a distributed object layer. Next comes multimodal assets: images, audio, video, documents, everything, all the materials modern models consume. And this is why S3 usage spikes every time a model release requires new data sets. 6. Cost optimization and tiering. AI data naturally moves through lifecycle stages, from hot to warm to cold to archive, from training to validation to reference, from active to dormant to legacy. The VPD supports lifecycle policies and price tier alignment by architecture, not by marketing. 7. Versioning, lineage, and reproducibility. Object-level versioning is critical for audit trails, controlled experiments, rollback, reproducibility, compliance, multi-team collaboration. This isn't an optional feature. Without lineage, AI becomes impossible to trust. The cloud today provides versioning. The VPD will provide versioning with sovereignty. Once internal usage is strong, once providers rely on the VPD for their own data, we move into a future where the distributed data center is not just an alternative cloud, but a data backbone for AI systems that need to be sovereign, compliant, or cost optimized. Imagine a biotech firm using a sovereign VPD for genomic data sets, or a media company storing terabytes of video for multimodal training, or an enterprise running a RAG system without relying on US hyperscalers, or a nation hosting its education and government AI data inside its own borders. This is the world we are building toward. Decentralization gives us resilience, but HostIO gives us intelligence. Inside every RelayerXM is HostIO, a routing, evaluation, and optimization engine that continuously monitors storage providers. Monitors their throughput, latency, uptime, location, durability history, block loss events, node responsiveness, cluster performance. From all of this real-time telemetry, HostIO continuously decides where each of the 120 blocks in a stripe should live. It doesn't just pick nodes, it scores them. Providers who lose data get fewer uploads. Providers with perfect records get priority. This happens today. Providers inside a requested region get selected first. This is how the network self-optimizes over time. The future of HostIO introduces natural language VPD configurations. Keep all my data within 200 miles. Prioritize the fastest nodes. Maximize durability, speed is secondary. Or give me the cheapest cluster that meets minimum thresholds. Or avoid nodes that have ever had a data loss event. Eventually, HostIO will draw boundaries that don't exist on maps. AI-generated service regions, defined by node performance, not geopolitics. This transforms VPD creation from a configuration task into a conversation, and maybe even a conversation soon where AIs will have the conversation with each other and configure the VPDs themselves. You tell the network what you want, it builds the data center you asked for because it understands the providers better than any human could. Okay, we've talked about the cloud, the economics, the architecture, and the emerging AI data landscape. Now let's talk about something equally important because it affects every person in this room and every person who will eventually join this ecosystem. The future of work. You thought I was going to say crypto price. The world is shifting at a speed that traditional labor markets simply cannot absorb. AI, robotics, autonomous systems, and hyper-automation are rewriting the relationships between people and income. Some of these shifts are obvious, some are quietly unfolding, but all of them point to the same conclusion. People are going to need multiple sources of income to live securely in the coming decade. Organizations like McKinsey, Deloitte, and the World Economic Forum have been consistent in their predictions. By 2030, 300 million jobs globally could be automated. 44% of all work hours in the US are automatable using technology that exists today. AI disproportionately impacts knowledge work, the segment once assumed safe. Younger workers increasingly believe traditional employment paths are unreliable. 1/3 of adults under 35 now expect to need multiple income streams for stability. It's not alarmism, it's analysis. Automation is reducing the value of generalized skills faster than the workforce can even adapt. And while new roles will emerge, prompt engineers, AI system managers, data curators, they will not appear fast enough to replace traditional middle income stability. And so this leads directly to a rising phenomenon. Web3 has introduced a new kind of economic participation. Small, distributed, cumulative earnings tied not to labor, but to infrastructure contribution, the means of production. These include compute, bandwidth, node operations, staking pools, storage networks, decentralized databases, distributed AI inference systems. It's not gig work. It's micro-infrastructure ownership. Gig work sells time. Micro-infrastructure sells capacity, and capacity scales. Instead of driving someone's food around for $14 an hour, income that stops the moment you stop working, you operate infrastructure that continues producing value while you sleep, work, or live your life. The distributed data center fits squarely into this category. But running a storage provider node is not labor in the traditional sense. It is participation. Providers add uptime and contribute bandwidth. They supply durable storage that forms regional clusters. They build out the physical backbone of the network. And in return, they earn predictable incremental income. This aligns economic incentives with network health in a way centralized clouds cannot replicate. Instead of paying rent to hyperscalers, you own a piece of the infrastructure. It's not going to replace a full-time salary early on, at least not initially, but it builds a second income layer that fits into the economic landscape we're entering, where autonomous vehicles reduce transportation jobs, where robotics run entire factories 24/7 in the dark, where AI is reducing white-collar roles, where globalized competition reduces wages. People need distributed, resilient forms of participation that provide income without dependence. Storage providers represent the next stage of that evolution, gig economy 2.0, but without the exploitation and burnout. And this is why the RelayerXM matters so much. It's not just a device. It's a gateway onto the new economic layers. Inside each RelayerXM is pre-configured VPD capability, personal cloud support, provider software, that HostIO intelligence engine, automatic updates, free storage allocations, and SPF token bonuses. And most importantly, a radically simplified onboarding. When someone unboxes a RelayerXM, they don't need to understand the blockchain. They don't know how distributed storage works. They don't run a Linux server. They don't have to manage Docker environments. They don't have to tune disks or RAID arrays. And they don't have to learn complicated network rules. They simply plug it in, it joins the network, it begins participating. This is the difference between decentralized infrastructure that grows and decentralized infrastructure that stagnates. The hardest part of decentralized networks is not engineering, it's onboarding. We've proved that over and over again for years. But the RelayerXM solves that, and putting the RelayerXM on all the current outstanding nodes solves it in spades. And in doing so, it widens the funnel dramatically. We'll eventually see students running nodes, retirees running nodes, small offices running nodes, rural communities adding their own regional capacity, entire countries launching sovereign distributed clouds. The economics reward it, the architecture encourages it, and the global labor trend demands it. We're entering an era where traditional jobs are shrinking, where financial volatility is growing day by day. Housing costs are rising like crazy, wages are stagnating, and automation is accelerating. Younger generations are not drawn to socialism because of ideology. They're drawn to it because they don't see pathways. Distributed infrastructure provides a real alternative. Ownership instead of dependence. Network contribution instead of platform labor. Community-driven economics instead of corporate extraction. And a fair share of value instead of being the product. In this model, people don't rely on a government or a corporation from California to secure their future. They rely on a system they help operate directly, tangibly, continuously. Running a storage provider node becomes practical and accessible. It's sovereignty aligned and economically meaningful. It's resilient against automation shocks. That's why the VPD and the distributed data center are more than cloud technologies. They're an answer to a generational economic challenge. Okay, we've covered the architecture, the economics, the role of providers, the future of work, and the massive opportunity emerging from AI. Now we need to wrap everything together by talking about the part of the system that binds incentives, participation, and ownership, the token economy. Tokenomics is not a side node in decentral infrastructure. It's the incentive layer. It's the economic flywheel. It's what binds providers, users, developers, and the broader community into a single aligned network. And to understand where we are now, it's important to understand where we started. SPF was minted in 2019 as a fixed supply token, 400 million total. Over 7 years, roughly 150 million of those were distributed to early supporters and contributors. It was never sold directly by the project. Every token that left the treasury went out as a grant, not as a sale. The key attribute of SPF is simple but powerful. It earns 15% of every storage contract on the network. This makes SPF a true infrastructure share, not equity, not a security, but a revenue participation asset tied to a decentralized storage economy. However, that same strength makes SPF difficult to list on centralized exchanges. The regulatory world is not ready for utility tokens that earn revenue share, even though this model is the backbone of decentralized infrastructure. So SPF lives in a kind of limbo, powerful but constrained. The breakthrough came when we bridged SPF into the Solana ecosystem as D2X. This transition accomplished several critical things: permissionless trading, anonymous acquisition, integration with DeFi, liquidity pools for both sides of the market, governance pathways, and a broad community able to access the token freely. This is why the bridge to Solana and DeFi is transformative for us. I just heard last night that OKX can now access all Solana DeFi assets. In the past, getting an OKX listing was very expensive, very time consuming. And here we are automatically. The Solana ecosystem layer unlocked an economic layer that had been dormant for years and made the token compatible with modern crypto infrastructure. SPF still exists. Plenty of people continue to keep them in cold wallets and just let them sit there and earn. But for people that want more active participation, D2X is the answer. The liquid, flexible, tradable representation that integrates with the broader Solana economy. With the transporter in existence, the logic became undeniable. We had to rebuild the token distribution model, not to inflate supply, not to reward speculation, but to align the token with the pivot we're making as a project. Beginning with this conference and continuing through the current 35 million token airdrop that runs until March of 2026, we're launching a multi-year distribution model designed to decentralize ownership and reward real contribution to the ecosystem. Our projection is to distribute roughly 40 million tokens per year going forward. The goals of this distribution are to decentralize the token supply, reward active participants, strengthen liquidity, align providers, users, and token holders, build an active governance base, ensure the token reflects network health, and create long-term consistency and incentives. Instead of waiting for enterprise clients to ignite adoption, we're turning to the community to spark it from within. The people who run RelayerXM devices, who use the personal cloud, who provide liquidity, who stake D2X, who help grow the network, they become the earliest and biggest beneficiaries of the new token model. Every March we'll host an annual event. Think Jupiter's Jupiary, except in March, where contributions are measured, points are finalized, distributions are executed, governance discussions take place, and the next annual roadmap is released. D2 becomes the heartbeat of the ecosystem. We've already implemented a limited controlled emission schedule using the transporter, the software bridge that handles SPF to D2X conversions. This gives us a predictable release structure, which is essential before adding more advanced governance layers. Starting in 2026, the community will vote on which contribution categories earn the most, provider performance metrics, distribution weightings, emission unlock timings, reward mechanisms for usage, and future upgrades to the VPD and network. This creates a path toward community-directed evolution of the entire system. Now let's be transparent about something. This reset forced us to confront a difficult reality. Investors do not fund potential. They fund revenue. Until our ARR, annual recurring revenues, reach a point where it can sustain the project entirely, the token remains our lifeline. Not because we want to rely on it, but because it gives us the ability to incentivize the community while retaining critical contributors. We can compensate the team. We can attract new development talent. We can expand the ecosystem and maintain operational stability. It's not a weakness of the model. It is the strength of decentralization, and one we ignored in the past. Okay, so all of this, the VPD, the RelayerXMs, personal cloud, HostIO, AI integration, provider economy, and token distributions, all come together in a big single idea: sovereignty over data, economics, infrastructure, identity, geography, the future you depend on. We're not trying to become the next hyperscaler. We're building the alternative to hyperscalers, a distributed cloud, owned and operated by the people who use it, without surveillance, without gatekeepers, without choke points, without political alignment, where infrastructure belongs to you. This is the blueprint for digital sovereignty, and this community is the group that brings it to life. Thank you for being here today. Thank you for believing in the mission, and thank you for helping build the distributed data center. Have fun with the rest of the conference, and I'll be hanging out to do Q&A with everybody. Thanks.